Assessment of interlimb strength asymmetries can potentially help identify athletes at risk of adopting dysfunctional or ineffective movement patterns that can negatively impact performance. Investigating interlimb asymmetries consists of comparisons between dominant and non-dominant, stronger and weaker, or non-injured and injured limbs. The article, published in the Journal of Strength and Conditioning Research, titled Measuring Interlimb Asymmetry for Strength and Power by Chris Bishop and colleagues, aimed to provide recommendations on the optimal way to assess, analyse and reduce strength and power interlimb asymmetries with athletes. This presentation, brought to you by Talking Sports Science, will provide a summary of their recommendations. There are 4 ways to assess interlimb asymmetry in strength tasks. First off, isokinetic dynamometry of the lower limbs can be used to provide a reliable and detailed profile of asymmetry, given that between limb data can be obtained for both the quadriceps and hamstrings at varying speeds of movement. This is useful if you want to bias an assessment toward either force or velocity. However, this equipment is often confined to labs. Whereas compound movements, for example the back squat and leg press, using free weights or stack machines, which are often prescribed in resistance training programs, can be used to obtain asymmetry data during actual training sessions. This increases external validity. These ISO weight testing methods are also reported to have excellent reliability. The isometric mid-thigh pull and squat, performed on twin force plates, can provide separate data for each limb and therefore can also be used to assess lower limb asymmetries. Although this approach is valid, not everyone has access to twin force plates. The Nordic hamstring exercise also may be used to assess lower body eccentric strength asymmetries. Although the research is still in its infancy, current evidence suggests that the unilateral isometric mid-thigh pull or squat tests and the Nordic hamstring exercise can be used as valid tests to assess lower limb strength asymmetries. Like strength, a wide variety of jumping tasks can assess interlimb asymmetries, for example, counter movement jumps, drop jumps, and a variety of horizontal hopping tasks, all of which has shown acceptable reliability data both bilaterally and unilaterally. Along with considering the needs of the sport, when selecting jump tests for the detection of interlimb differences, it needs to be decided whether the test should be unilateral or bilateral in nature, as these tests offer different information. Therefore, one test should not be used to represent the other. In bilateral jumps, because 2 limbs are involved, it allows for a greater total power output, jump height, and concentric and eccentric velocity, compared to unilateral jumps. Logically, bilateral jumps could be preferred in sports where such bilateral movements are more common, for example volleyball. Although unilateral tasks may not allow for force and power compensation between the limbs during the task because only one limb is used at a time, unilateral jumps may be a better measure of actual limb capacity, and therefore potentially more sensitive at detecting asymmetries. This is because an asymmetry measured during a bilateral task may be masked by a compensation strategy, whereas an asymmetry measured unilaterally may be considered more of an imbalance in jumping capacity. It's also important to understand specific characteristics involved in the task. This is because asymmetry is highly task and metric specific, meaning if an asymmetry of 5% or 10% is achieved in a given test, it should not be assumed that the same or similar values would be achieved in another test. In addition, although group mean data rarely changes significantly between test sessions, analysis of individual data shows that asymmetries can vary considerably between the sessions. Therefore, when assessing asymmetry, individual analysis is recommended. Moving on to analysis of asymmetry. Regarding within-session analysis, asymmetry should only be considered real if the between-limb percentage value is greater than the intra-limb variability assessed with a coefficient of variation. If an athlete exhibits a real asymmetry, it may not require an immediate intervention to correct the imbalance. However, awareness of persistent real asymmetries, i.e. repeated test sessions over time, may highlight potential limb capacity issues that may need to be addressed. During test-retest designs or longitudinal analysis, comparing changes in asymmetry to the baseline coefficient of variation values would confirm whether changes in the signal, i.e. asymmetry, are greater than the noise, i.e. baseline coefficient of variation. When assessing percentage change, the difference between the time points is typically computed relative to where it came from, i.e. baseline. Another point to consider is the direction of asymmetry. It's important to remember that asymmetry is a ratio, making it composed of two individual parts, i.e. dominant and non-dominant limb scores. Therefore, when asymmetry is treated as a single number, no context is provided for which limb performs superiorly. The kappa coefficient statistic enables analysis of the levels of agreement for the direction of asymmetry, i.e. limb dominance, between test sessions. Simply, the concept can be explained by the following example. If an athlete jumps higher on their dominant leg initially, the next testing session will aim to establish whether the dominant limb is still outperforming the non-dominant side. Intuitively, it might be thought that no obvious reason exists as to why this should fluctuate between test sessions, especially if no training intervention has been completed. However, evidence has shown that levels of agreement between test sessions are far from perfect, indicating that fluctuations in limb dominance may naturally occur, and the reliability of asymmetry of some tests may be low, highlighting the importance of test reliability before incorporating them into a monitoring strategy. It is recommended that athletes who show these natural fluctuations between limbs may not need any specific intervention, whereas those who exhibit consistent limb dominant patterns over time may need specific targeted training interventions. To help reduce asymmetries, 3 training methods are proposed, which include traditional resistance training, flywheel resistance training, or using a combination of different resistance training methods. However, to help draw firm training guidelines to reduce asymmetries, greater methodological rigor should be applied towards study design, data analysis, and interpretation of future investigations. And that concludes this presentation. I recommend you check out the full article. The link is in the description. Thanks for listening, folks. See you next time.